Welcome to this explainer. Today, we're looking at something pretty wild, the life cycle of a complex industrial machine. We're going to trace exactly how organizations take this massive, multi-million-dollar idea from just a tiny little post-it note stuck on a whiteboard, all the way to a high-performing beast that's humming away on the plant floor. It is a massive undertaking, and honestly, a single millimeter of error here can literally cost thousands of dollars.
So, 27. That is our magic number today. It takes exactly 27 distinct stages to turn a business need into a production-ready machine. Now, I know what you might be thinking. You're probably saying 27 stages? Come on, that just sounds like corporate red tape. But listen, in industrial manufacturing, skipping steps just to save a little time? Yeah, that is usually the fastest possible way to inherit a catastrophic budget-crushing failure.
To make this all a bit more digestible, here is our roadmap for these 27 stages, broken down into 6 logical sections. First, we define and evaluate the need. Next, we procure the right supplier. Then, engineer and build the machine. After that, we deploy it to the plant floor, validate the production process, and finally, close and hand over.
Let's kick things off with Section 1, Define and Evaluate the Need, covering phases 1 and 2. Now, this brings us to the User Requirement Specification, or the URS. Think of this as your foundational document. It's essentially your absolute North Star for the entire project. Before anyone even thinks about picking up a wrench or drafting up a 3D model, your end users have to sit down and document exactly what they expect this machine to do.
So here is how that actually plays out in the real world. First off, a formal charter gives the project the green light. Then, that URS we just talked about dictates the what. From there, the engineering team takes that what and they start brainstorming the how. But this is the crucial part. Before anyone writes a massive check, that concept goes through a pretty brutal feasibility study just to ensure it won't break the laws of physics or completely blow up your budget. And only after it survives that stress test does it finally become a detailed technical specification.
Moving right along to Section 2, Procure the Right Supplier, which is Phase 3.
You can really think of this phase as a high-stakes matchmaking process. You start by issuing a formal RFQ to capable suppliers. Then the proposals start rolling in, and you have to ruthlessly evaluate them based on both their technical brilliance and, of course, the bottom-line value. Once you pick your absolute perfect partner, you don't just hand them a blank check. No way. You review their proposed design meticulously. And only when everything is completely airtight do you officially release the purchase order.
Up next is Section 3, Engineer and Build the Machine, covering Phase 4.
This is where the sparks literally start flying. Detailed engineering takes those paper concepts and transforms them into massive bills of materials and incredibly complex control systems. After one final, formal design approval, the supplier actually fabricates and assembles the beast. But before it is allowed anywhere near a shipping truck, it hits a major roadblock, the Factory Acceptance Test.
The Factory Acceptance Test, or FAT, is basically your ultimate safety net. Why is it so absolutely crucial? Well, because realizing your brand new machine is a dysfunctional mess when it's already sitting on your plant floor, thousands of miles away from the engineers who actually built it, is, quite frankly, a career-limiting nightmare. The FAT forces the machine to prove itself on the supplier's turf before it ever leaves their facility.
Which brings us to Section 4, Deploy to the plant floor, which is Phase 5.
Let's be real, the reality of deployment is completely chaotic. Before the shipping crates even arrive at your dock, you're already pouring foundations and routing utilities. Then, the machine is dispatched, unpacked, and installed, and we mean laser-aligned down to the absolute millimeter. Once it's completely bolted down, it faces the Site Acceptance Test, which is then followed by commissioning to bring the whole system fully to life. Now, the Site Acceptance Test, or SAT, is the ultimate reality check. See, a machine might purr like a kitten in the supplier's pristine, air-conditioned lab, but the SAT, that proves if it can actually survive the harsh reality of your plant floor, hooked up to your dirty power, your compressed air, and running with your everyday operators. So what we have here is a brilliant dual-layer accountability system that prevents total disaster. The FAT guarantees the supplier actually built what they promised. The SAT guarantees it actually survives and works in your specific environment. You simply cannot have one without the other, for sure. Moving right into Section 5, Validate the production process, covering Phase 6.
Okay, so the machine has power, but is it actually reliable?
Process validation is what proves it can hit the required output batch after batch without any weird variations. We finalize the standard operating procedures, and critically, we train the operators and the maintenance teams. We put the whole thing through a pilot run just to work out those final kinks, and only then do we take off the training wheels and scale up to a full production rate.
And finally, Section 6, Close and Handover, which is Phase 7.
This is where we finally cross the finish line. Performance qualification confirms that this machine isn't just a one-hit wonder. It's actually going to sustain its numbers over time. The keys are then formally handed over to operations, and finally, the project is officially closed out. Crucially, the lessons learned are documented so that when you go to build the next machine, your team is already one huge step ahead.
So, the big takeaway from this entire explainer is right here. 27 stages, 7 phases, one single unbending discipline. This framework isn't just some boring bureaucracy. It is truly the only reliable way to take a concept from a piece of paper and operationalize it without running into crippling delays or massive budget black holes.
I'll leave you with this final thought to consider about your own operations. When you bring new, multi-million-dollar equipment online, are you strictly following the discipline, or are you just crossing your fingers and skipping steps? The answer to that question might just be the difference between your next great production win and a very, very expensive paperweight. Thanks so much for joining me for this explainer.